In section 8.4, we're going to work on how it is that we solve polynomial equations, and that's our learning objective. We're going to start by doing that in factored form. So once we've learned to factor, we've been working on factoring polynomials. Once they've been factored, how do we identify the solutions? That's what we're looking at. And our vocabulary is roots, and quite frankly, the roots of a polynomial equation are the solutions. So those are the same item, essentially. And we're also going to work with a vertical motion model. So what happens, basically the effects of gravity on an item in motion in terms of its height from the ground versus time. Okay, so a key element here for all of the study of polynomials that we're going to be doing is this idea of the zero product property. And it basically says if I have two values, a and b, and they're being multiplied together, and that's what factors are, they're things that are being multiplied together. If a times b is equal to 0, then either a is equal to 0 or b is equal to 0. And what that means for us in polynomials is that once I've factored my polynomial into different items that are being multiplied together, if I take each of the factors and set it to be equal to 0, I will find the solutions because, if we look down here in this example, if the value z minus 13 times the value z minus 14 equals 0, then either z minus 13 must be equal to 0 or z minus 14 must be equal to 0, because in order to multiply two things together and get a product of 0, one of them must also be equal to 0. So if I set z minus 13 to be equal to 0, I'll find that z could be equal to 13. And if I set z minus 14 to be equal to 0, I'll get z is equal to 14. And these are the solutions. And these are also called the roots. So we may call them solutions and we may call them roots. Those are the same items. Okay, to go through that a little bit more here, if I set 3n plus 11 to be equal to 0, I'm going to subtract 11 and then divide by 3. And I get negative 11 thirds. For my other solution, n plus 1, if I set that to be equal to 0, I'll get n is equal to negative 1. So n is equal to negative 1, or n is equal to negative 11 thirds. Okay, so going back to the idea of factoring, we're going to start with the simplest factoring, which is finding the greatest common monomial factor. And this is always where we should start. When we're given a new polynomial and told, oh, solve this, you should be looking, is there a monomial factor that I can factor out of this? And in this case, you can see that s is in each of the terms. So I could factor an s out. And when I factor an s out of this, this becomes 3s to the third plus 16. Okay, and when we want to, right now we're just working on factoring. We're not going to go through and solve at this moment. But if I wanted to, that means that either s is equal to 0 or 3s cubed plus 16 is equal to 0. This example is not intended to do that, or it would say is equal to 0 up here. And when we were to proceed through with this, I would have subtracted 16 and divided by 3, and then taken the cube root of either side. Okay, so I'm going ahead and pushing through to solving. That's not what they're expecting you to do at this point. If I look at this, you can see that, well, m squared is a factor of each item, and so is 3. So when I factor a 3 out of the 9, I'm left with 3. And when I factor m squared out of m to the 7th, I have m to the 5th. And this and that are the same item, so I factored this factored out of that will just be 1. Okay, and again, anytime I have a monomial, this provides me two solutions, 0 and 0. It's a repeated solution, and this will provide me with 5. If I set 3m to the 5th minus 1 to be equal to 0, I'm going to add 1 and divide by 3. I'll get m to the 5th is equal to 1/3. So m would be equal to the 5th root of 1/3. Okay, and that's going to provide me with more solutions. Okay, so let's move along. What we want to make sure we do is we get things in the correct order before we start factoring monomials out. So over here, I want to get the 10s to be over on the same side of the equation. So I subtract it from either side. And I see that I can factor an s out of each term and also a 2. So 2s out of 4s squared becomes just 2s. And 2s out of negative 10s becomes negative 5. And if I keep going through to solve, that means that 2s is equal to 0. So s will be equal to 0. And 2s minus 5 would be equal to 0. If I add 5 and divide by 2, s is equal to 5/2. Okay, now over here, whenever possible, I would like to keep my leading coefficient positive. So I'm actually just going to multiply both sides of the equation by -1. So I'll get 10n squared minus 35n is equal to 0. This is the same as if I had added 10n to either side and subtracted 35n to either side. Same thing. And you can see I can factor an n out of each term, and also I can factor a 5 out of each term. So when I factor 5n out of 10n squared, I'll get 2n. And when I factor a 5n out of minus 35n, I'll get minus 7. 5n is equal to 0, so n would be equal to 0. And if 2n minus 7 is equal to 0, I'll add 7 and divide by 2. N is equal to 7/2. Okay, so that's working through using the zero product property and factoring a monomial out. We're going to do more factoring as we continue through this chapter, but we're always going to finish up by using the zero product property. Now let's take a look at vertical motion. So when we look, this is a vertical motion model, and what it tells me is the height, h, can be modeled versus time by using this negative 16t squared. That, by the way, is the effect of gravity, plus v times t. V is initial velocity, so the things I need to know is I need to know the initial velocity, and s is the initial height. So at the start of my situation, whatever's being described, I need to know how high is it and how fast is it moving when we start. And then I can find the height based on time and using this equation. Okay, if I'm dropping an item, you're going to see later in this chapter, I'm sure we'll talk about an item being dropped. When an item is being dropped, the initial velocity is 0. So you'll have negative 16t squared plus 0t plus s, and that means this term will drop out, so it'll just be negative, 16t squared plus s for an item being dropped. But it's not a different formula. Okay, so if you just work with this formula and remember that if the item's being dropped, the initial velocity while it's sitting in your hand before you drop it is 0. It'll all work out for you. Okay, so I've got an armadillo who gets scared, and he jumps up into the air with an initial velocity of 14 feet per second. How many seconds, after how many seconds does it land on the ground? Well, remember, if it's on the ground, that means its initial height is 0. So the height will be negative 16t squared plus 14t plus 0. Okay, and so the plus 0 will just sort of drop out. If we're going to substitute 0 in for h, because that's after how many seconds does it return to land on the ground, that means its height is going to be 0. Negative 16t squared plus 14t And if we look at this, you can see that I can factor a 2t out of each of these. In fact, I could make it a negative 2t. That might be helpful. That means that this would become 8t, and it'd be minus 7. And if I have negative 2t is equal to 0, then time is equal to 0. And we're going to talk about that in a second. And then I have 8t minus 7 is equal to 0. So t would be equal to, add 7 divided by 8, 7/8 of a second. Okay, so just about a second. But what is this t is equal to 0? Well, at time 0, if you remember, that was the initial height of the armadillo was 0. And if you think of this as sort of the shape that the graph of height versus time would take, the armadillo started here at 0 seconds at height 0. That's the starting point. So this is not really our answer. And over here, it returned to 0 height at 7/8 of a second. Okay. And that is section 8.4.